Four things you got to learn this week. One of them was centroid. You learned that yesterday. Today is mid-segment theorem. Starts off kind of like a centroid. You got to split the outside sides in half. So D is the midpoint of AB. It splits A and B in half. That's why I have a tick mark here and here because DB is equal to DA. If you split something in half, you have two equal parts. Same with over here. Now with the centroid, we connected the midpoint D to the opposite vertex, and we can connect the midpoint E to the opposite vertex B. With mid-segment theorem, we're just going to connect the midpoints themselves like this. And now that new segment DE that we created has two special characteristics. One of them is the length of DE is equal to half the length of BC. The mid-segment is always half the length of the side you're not splitting in half. So if you make a mid-segment from here to here, we're not worried about this side or that side because that's the side we split in half. We're worried about the third side that we didn't use, and it's always half the length of that. Another way to say that is 2 times DE is equal to BC. It's like saying DE is half the length of BC, or BC is twice the length of DE. 10 is twice as long as 5, or 5 is half as long as 10. They mean the same thing. Right, that's one thing to know. The lengths are half. Another thing to know is that they're always parallel. DE is going to always be parallel, and the two lines like that is the symbol for parallel to BC. Those are the two special things about mid-segment theorem. It says two things, half the length and parallel to BC. Now how this is going to show up as problems would be if this length is 6, what is the length of BC? Well, BC would be 12. It's always twice as long as DE. Now the problems won't be quite that easy. They'll both probably have an x in it. Like say 2x plus 5 is equal to 5x minus 13. In this case, it looks a little more difficult to solve for x. You have to create your own equation. Well, the best way to do this is to set these two quantities equal to each other after you change one of them. Remember, this length is half as much as that one. So if we double this length of DE, it's going to be the same as BC. So if DE is 6, BC is 12. It's always twice as much. So we have to double DE to get it to equal BC. So you can do that even though it's not a number. Right now, DE is represented as 2x plus 5. To double that, you just multiply the whole thing by 2. You distribute a 2 through the whole thing. And that becomes 4x plus 10. That's double DE. Now that amount right there is going to be equal to this amount because twice the length of DE is always equal to BC. Now we can set them equal to each other. 4x plus 10 is equal to 5x minus 13, and we can get busy solving for x. When you have an x on each side of the equal sign, you got to subtract 1 to the other side. I'm going to move the smallest one so that my x's stay positive. And you end up with 10 is equal to x minus 13. And to solve for x, you get rid of the 13 by adding it to the other side, which is 23. So x is equal to 23 in this problem. If you wanted to check your work, which is always recommended, you would plug a 23 in for x. This would be 2 times 23, which is 46, plus 5. That would be 51. This would be 5 times x. 5 times 23 is 115. Minus 13 is equal to 102. And lo and behold, we did it right. 102 is twice as much as 51. And that's what we need. All right, so that example right there is how you do mid-segment theorem problems. Another type of problem that you're going to have would be triangle sum theorem, which is just a fancy name for something that you already know, which is angle A plus angle B plus angle C is equal to 180 degrees. 3 angles in a triangle add up to 180 degrees. That should not be a big surprise to you all. And again, you can use that information to find a missing angle. So if this is 70 and this is 50, what would x be? Well, it would have to be some number that made these three add up to 180. Right now we have 70 plus 50 is equal to 120. What's the difference that we need to make up to get to 180? If you can't do that in your head, you can do 180 minus 120, which is 60. So x must be equal to 60. But again, like mid-segment theorem, they're not usually going to be that easy. You might have something about the theory of it or the concept of it. For example, let's make triangle ABC here. What if angle B plus angle C is equal to 90 degrees? So for example, let's say this is 50 and that's 40. What would that say about angle A? Well, angle A would have to be equal to 90 degrees also, because 90 plus 90 is 180. What if angle B plus angle C is greater than 90 degrees, say 50 and 50? What could you say about angle A compared to 90 degrees? You could say that angle A is less than 90 degrees, which in fact is true. Angle A would be 80 degrees. And then the third option along these lines, let's say angle B plus angle C is less than 90 degrees. So for example, it equals 80. What could you say about angle A compared to 90 degrees? You could say that it's greater than 90 degrees because it's 100 degrees. It's greater than 90. If these are 80, that must be more than 90. It must be 100. All right, you could also have algebraic problems with this. So you have x, 4x, and 5x. And you have to solve for x. That might look a little intimidating. 3 different expressions with x in it. It's still triangle sum theorem. You still have to add all these 3 up and set them equal to 180. So you do 5x plus 4x plus x. All 3 of those angles are always going to add up to 180 degrees. Now you can solve for x. Combine your like terms. We have 4, 5, and 1. We have 10 x's is equal to 180. Therefore, x is equal to 18. 180 divided by 10. Now we just solve for x. We just did it. X is 18. So that's how you would do that. What's another way you could have a triangle sum theorem? They could ask you to find the length of an angle outside of a triangle. You might have something like, how big is that angle right there? And they could give you, say, 50 and 35. Well, this is one where people make a mistake on this a lot. They think they're so used to triangle sum theorem, they say, okay, this has got to add up to 180. So they do 50 plus 35 is 85. What goes with 85 to make 180? 95 does. So they say x is equal to 95, which will be one of the choices, and that would be incorrect. You would be wrong on that one. What is equal to 95 is actually the third angle inside the triangle. Triangle sum theorem deals with angles inside of a triangle. So that one's 95, which we can use to figure out x, because not only are there 180 degrees in a triangle, there are also 180 degrees in a straight line. So if this one's 95, what goes with 95 to make 180? 85. So x is equal to 85 in this one, not 95. All right, those are your 2 lessons for today, triangle sum theorem and mid-segment theorem. Tomorrow I'll make a short video about isosceles triangles. But that's it. This test is usually one of the easier ones of quarter 2.